Right, got a modulus question here from the International A-Level, the Pure 3 paper from October 2020, the new specification. Got a modulus, a negative modulus, so we've got an upside down one, so it's like an upside down V. We've got a restricted domain as well, so X is greater than equal to naught, and it asks us to do a few things with it. We're going to look at the graph first of all, though. Remember the modulus, it might be just 2 minus x, or it might be minus that, because to make it positive, we just stick a minus sign in front. So I'm going to look at the two possibilities. So f of x might be 21 minus 2 minus x, if it's just the positive one, which is 17 plus 2x. Now that's this part of the graph, because we've got a positive gradient. It's going to hit the y-axis at 17. The other one, it might be 21 plus 2 lots of 2 minus x, which gives us 25 minus 2x. And that's that part of the graph. Got a negative gradient, and that's going to hit the x-axis at 12.5. Later on, we need the coordinates of this vertex. At the vertex, these two are going to be equal to each other, so we can solve them sort of simultaneously. And then we get x is equal to 2. You could just look at this and think, yes, I've got 21 minus a positive, so 21 minus 0 would give me a maximum. So that 2 minus x needs to be 0, so x is 2, and then and that'll give us a y value of 21 then at a maximum. You don't need to do all this, but we need the vertex for later anyway. I thought I'd just show you what the graph looks like. For the question, then we need to do ff of 6. So standard thing, composite function to do f g of a. We do g of a first and do f of whatever that is. Doesn't really matter with this one because it's ff of 6. This is what most people would do. They just stick 6 into the function. 2 minus 6 is minus 4. The modulus of that is just 4, so it's 21 take away 8 really, which is 13. And then we put 13 into the function. So put 13 in for x here. 2 minus 13 is minus 11. The modulus of that is 11. And that gives us minus 1. Looking at the graph, though, we can look at it as a piecewise function, where the first part of the graph between 0 and 2, the graph is 17 plus 2x, and then it's 25 minus 2x after that. We're looking at values that are bigger than 2 because we're putting 6 in, which is bigger than 2, so we just stick into this one. So 6 is bigger than 2. 13 as a result is bigger than 2. So we just put 6 into this one and do 25 minus 12, which is that 13, and then 25 minus 2 lots of 13, which gives us that minus 1, instead of doing all this. The part B says solve the equation f of x equals 5x. That's a line through the origin. If I think about where 2 is on the graph, it'll have coordinates 2, 10. Which is lower than 2, 21. So this line is only going to hit this part of the graph, the 25 minus 2x. So I put 5x equal to 25 minus 2x, giving me x is 25 over 7. And it says the equation f of x equals k is exactly 2 roots. Well, if I drew the line y equals k and I put k equals 17, it looks like this. And there I've got 2 roots. 0 will be one of them. And that will actually be 4 because of the symmetry of it. I could move it up a little bit as well. I'd still got 2 roots, but I couldn't go right at the top because there would only have 1 root. So the k needs to be at least 17, but not as much as 21. And you'll need to get both these inequalities right to get both marks there. And then it says the vertex of the graph, which we know is 221, with equation a f of x minus b is 6, 3. A and b are constants. We're going to find the value of a and b. So 221 goes to 6, 3. This y equals that. Well, it adds b to the x value, x minus b. So we've gone from 2 to 6, which is adding 4. So the b must have been 4. And it multiplies the y value by a, 21 to 3. So we multiplied by 1 over 7. And there we go.